Okay. So this is the last lesson of Unit 4, okay? I know we're going by so fast. This is Lesson 7, and it's very similar to Lesson 6 in that we are still using exponent laws. Those 3 exponent laws we just reviewed in Lesson 6. We'll use those all again. The only difference is here with these examples, there are now letters, okay? I'll zoom in a little bit. So there's our first question. Instead of our bases being numbers, they are letters, okay? Some students actually find it easier because you can't evaluate x squared, right? So once you get to something like x squared, you're done. You don't have to go as far, okay? So here, question number 1, I have x to the 3, y to the 2, all multiplied to x squared, y to the negative 4. So we are going to start by using our exponent laws. Which exponent law could I use here, do you think, when you're multiplying things together? What law is that, Blessing? I'm sorry? You add them, right? So first we're just going to look at the x's. I have 3 in the first bracket, multiplied to 2 in the second bracket. You add them, you have 5. You do the same thing with the y's. You have 2 in the first bracket, it's added to negative 4. So be careful. 2 added to a negative 4 is actually 2 minus 4 is actually minus 2. So we're still stuck with a negative exponent, but we know how to take care of those. Whenever you have a negative exponent, you just take that base and send it down in this case because it's already up high. So what happens to that x5? Stays where it is because that x to the 5 did not do anything wrong, so he will stay up top in the numerator, right? So imagine you have your denominator down there, that y is sent down, so he will now be underneath the x to the 5 and becomes positive, and we're done because you can't evaluate anymore. You can't evaluate an x. It just is what it is. It's x to the 5. And we're done. Okay? Questions about that one? Number 2. All right, so now I'm throwing in a couple more things at you. First of all, it's a division. And second of all, I have 2 fat numbers out front. I have a 10 out front and a 2 out front in the numerator and denominator. So I'll let you get that down and we'll go ahead. So we know when we have a fraction like this, it means division. So I want to divide the top by everything underneath. So starting, let's just work left to right. Starting with that 10 up top, divided by the 2 down low. It's 10 divided by 2. 5. So that just becomes a 5. Now with the a's, if we're working our way to the right, I have 5 up top, 2 down low. This is the division law. This is law number 2. You're allowed to subtract those exponents. So 5 take away 2, I only have 3. And then same with the b's, we will subtract the b's as well. So be careful here. This is where mistakes happen. You have 3 up top already. You are subtracting off the already negative 2 on the, so it's actually 3 plus 2. So it's actually 5. So that all becomes b to the 5. You can't evaluate a's or b's. You're done. So pretty simple, hey? Not so bad. Questions? Next one. All right. Now I'm throwing a few extra things at you. You have exponents that are fractions now. Okay, so once you get that down, I want someone to tell me what's the first thing I'm going to divide. Yeah, 4 by 2. Same thing as we did number 2. 4 up top divided by 2 down low. I actually just have a 2. All right, now with my a's, if I have negative 2 up top and it's a division, so I'm subtracting the 2 down low, how many a's do I actually have? Negative 4, right? Negative 2, take away 2 more. Negative 2, subtract 2, negative 4. So I have a to the negative 4. Now with the b's, I have fractional exponents I can subtract. So I'm going to write that over here. I have 2/3 up top minus the 1/3 on the bottom. You already have common denominator, so you just go ahead and subtract the tops. 2 minus 1 is 1. Easy. So then you write that down, b to the 1/3. So we've kind of we've removed everything from the bottom, right? Because once we do that subtracting, the answer just goes up top. The answer defaults to the top. One of my students in period 1 asked that question, is why is there nothing left on the bottom anymore? It's because when we do this subtracting step that we did over here, the answer defaults to being in the numerator and we have no denominator anymore. But I'm actually going to have a denominator in the end. Why? Because there's a negative exponent. So this term right here, we need to take care of that, right? We can have a negative exponent in the answer, but that's the only thing that's negative, so that's the only thing that's going to move. So I'm just going to go down here. So that 2 stays up top. He didn't do anything wrong. Same with the b to the 1/3. But that a just gets set down underneath the 2 of them, and it becomes positive. And we're done because we have exponents on the b's and the a, but we can't evaluate exponents. Or sorry, we can't evaluate variables, excuse me. So we're done. I can't really find the cube root of b, so I just stop. Is anyone finding this easier? Yeah, you are? Okay. Number 4. So I really need you to pay attention to this one. I chose this example for a reason. You know how I always kind of go on a little rant about the common mistakes kids make, and no matter how many times I say not to do it, kids still do it? This example has one of those. There is something in here that I will say till I'm blue in the face that you need to do, but students always forget to do it. Okay, so first of all, what law would I use here? Is there anything in the bracket I can do? I have an 8, A, and B in the bracket. I can't do anything with those guys in the bracket. So what do I do? What law do I use first? Yeah? The third law. The third law says when you have an exponent kind of on the outside, it gets sent in, and what operation happens? Multiplication. That's law 3. Remember this guy? It's kind of an extension of this law. But here's the thing, when we send the m in here, we only sent it into the n. But when we send this 1/3 in, it gets sent in to every exponent that's in the bracket. So it'll get sent into the 6, it'll get sent into the 3. Students do that very well, and this is where they stop. And this is the mistake that's made. What do I need to do? Send it into the 8. You send it into every exponent in the bracket. We can't forget that that 8 has an exponent, doesn't it? So because there's 3 terms in the bracket, I should see 3 arrows. Okay, and when you send that in, the operation is multiplication. So let's go ahead. So when I send that 1/3 into the 8, because it's just a 1 there, well, 1 times anything is anything. So it's the 1/3. Now I'm going to do this calculation over here. When I send it into the 3 that's on the A, it'll be 3 times that 1/3. You just multiply the top numbers together, which is 3 times 1. And the bottom is just a 3. It's really just a 1. That's what happens to that A. It becomes A to the 1. You don't have to write the 1. Then we do the same thing with the 6 on the B. So it's 6 times 1/3. You multiply the top, that's 6. Down low stays a 3. You reduce that, it's a 2. Okay. Now I've always said we can't evaluate exponents that are on letters. Like I can't find. But what could I do here? There's an exponent also on the 8. And you can evaluate that because that's really asking you for the cube root of 8, isn't it? Remember that lesson we learned the first half of the unit with fractional exponents? So really the question becomes that, and then ends up being that. Cube root of 8 is 2. We're flying, actually. We'll be done by lunch for sure. Are there any questions, though? We've got a few more. Okay, I see some people still writing, so I'll let you get that down. Okay. Holy smokes. Number 5 is a doozy. Copy that down correctly. That's step number 1. I'll give you a sec. So, just like examples, example number 2, I believe it was, where it's just a division, we just work left to right. And we divide one set of terms at a time. So if I look left to right, the first term I have is 12 and 3. 12 on top, 3 on the bottom makes 4. Okay, so I have a 4. And remember, the answer kind of just defaults to the top. All right, this is where it can get nasty, so stay with me. I have the x's, right? So now I have to take this exponent and minus that exponent, because we're dividing x's, we subtract the exponent. So I'm going to do that over here. So I have negative 5, and then I'm subtracting a 1/2. When you subtract fractions, what do you need? Common denominator, and they don't have it. This 5 is technically over a 1. But I can very easily find common denominators by multiplying it by 2. Now they're both over 2, right? But what I do to the bottom, I have to be fair and do to the top. So this becomes negative 10 on the top over 2 minus 1 over 2. What's negative 10 minus 1? Negative 11 over 2. You with me? Okay. So we did all of that so that my base can remain an x, but now has an exponent of negative 11 over 2. We do the same thing with the y's, but lucky for us with the y's, why are we lucky? Because they already have the same denominator, right? So all you do is you go 5 over 2, but be careful, it's minus an already negative 1 over 2. So really we end up adding them. You see what I mean? Because we're subtracting a negative. So 5 plus 1 is 6 over 2. That all comes down to just being a 3. There. Who can tell me what my last step would be? Emily? Yeah, this guy is causing a problem. So just like in the example above, the 4y cubed didn't do anything wrong, so it'll stay where it is. But this guy gets sent underneath. The exponent just becomes a positive 11 over 2. And we stop. Okay, how are we doing? I'll let you get that down. People are still writing. Okay, how many more do I have? Last one, folks. This is it, the big kahuna. Do you guys want to try? Well, I'll give you till 12:20. That's 3 minutes. And then we have 5 minutes to correct it. So if you're listening from home, you can just fast forward about 3 minutes. don't even pay attention to this guy at the very end. Okay, so it's 12:20. So just to make sure that we're out by the bell, we're going to correct this. So as I said, ignore that 1/2 on the very outside. We will deal with him later. We're going to deal with what's in the brackets first. Okay. So just like some other questions we've done, we kind of just work left to right. We have a 100 on top and a 25 on the bottom. So we know that that's going to equal a big fat 4. And I'm going to keep brackets around this because there's the 1/2 that's on the outside. We have to remember about him. Now the A's, who can help me? What did we get for A's for the exponent? Blessing? -4, that's right, because there's a 1 here, right? 1 minus 5 is -4. Okay, now what happens with the B? There's actually a couple different options here. Stacey, what did you do? You just left it exactly as it is. Right, because there's no other B, right? So he has no friends to like combine with, so nothing happens to him. So option number 1 is, whoops, to keep it on the bottom and just not change it. Does that make sense? Is that okay? Because nothing happened to the B, so it should just stay down low. So that's one option. Did anybody do anything else? Blessing, did you bring it up? Okay, so that's fine. Either works. So I'm just going to continue with this way because that's what I have written down. But just to let you know, what Blessing did was she saw this and she said, okay, let's bring it up so that it's beside the A and became positive 1/2. Either option is fine, and you should get the same answer in the end anyway. Did anybody move the A down? Not yet? Okay. So if we have this is where it gets a little bit crazy because we have nothing left to do in the bracket anymore. So the only thing left to do is law 3, where we send the exponent on the outside in, but we have to remember it gets sent to every exponent that's living inside the bracket, and there are 3. There's the 1 on the 4. Right? So when we send it in, it would become 4 to the 1/2 A to the negative 4 on 2. That's what I get when I go negative 4 times 1 over 2. Then down low, what's 1/2 times 1/2? 1/2 times 1/2 is 1/4. But when I multiply 1/2 to the 1/2 down there, it's still negative. It's a positive times a negative. Okay, so that's where I'm at. Now I'm going to take care of a few things. So if I kind of again work left to right again, I have 4 to the 1/2, which is just 2, right? Because that really just means we're square rooting the 4. We know that by now. To the 1/2 means square rooting. Then the a, I'm going to simplify this to a negative 2, right? Negative 4 over 2. So it's negative 2. And on the bottom, nothing can happen with that. So I've simplified a couple things, and now I have to take care of the negative exponents. So this a will go down, but the b will come up. They're both negative, but that 2 does not move. So we still have the 2 up high. That b comes snuggled up beside the 2 now and becomes positive. And then the a gets sent down and becomes positive. And so, Blessing, you did it the other way. You brought the b up first. Did you get the same answer in the end? But do you see what your mistake was at least? Okay. So there are different ways of doing this, a different order of operations, but you should end up with the same answer in the end. Are there any questions about that? Okay, so is this easier or harder than lesson 6? Is it about the same? New stuff, new problems? Okay. So there you go. So I'm going to get you to copy down this textbook assignment as well. But just remember that you have nothing to do at home on Monday. Right? You don't have a new lesson to learn on Monday. So I'm kind of reserving Monday as a homework day. Okay, yeah. I'm sorry? You're still writing, sorry. I'm going to stop this recording now.